بسم الله الرحمن الرحيم والصلاة والسلام على رسول الله نبينا محمد صلى الله عليه وسلم وعلى آله وصحبه أجمعين. My name is Mutaz Ilhaq. My email address is mutazilhaq@gmail.com. I'm making this virtual lab to test my knowledge in networking. First of all, I ask myself, what is networking? I'm going to use a simple analogy. It's like if we look at the internet, for example, it is a huge network which is like connecting devices together. Like for example, from home to home, and there is many type of network. There is a local area network, a LAN, which is basically connecting computers in one home, for example, like 3 or 4 computers together, or in a company, like connecting in a company. Geographical wise, it's like one building connecting their computers together. This is a LAN, local area network, and there is a WAN, wide area network. And the WAN basically is like connecting computers from, for example, from city to city. And there is many kind of WAN technologies like frame relay, ATM, SONET, MPLS, ISDN. There is many type of WAN technology. So I'm going to move to a very important topic, which is what is the IP? The IP address. The IP address is Let me talk first about the OSI model. The OSI model is starting from the top. From the bottom. I can start from the top, which is the application layer. Then application presentation layer. Then session layer. Then network layer. Then transport layer. Sorry, no, it is a transport layer. That's layer 4. After the session layer is transport layer. Then the network layer. Then network layer. Data link layer. And the physical layer. So I'm going to start from the bottom. What is the physical layer? The physical layer is just the signal itself in the wire. It is like the bit, which is like 0 and 1. It's just the signal. The data link layer. This is for example, in the Ethernet world, this is a MAC address, which is like any NIC card has I mean, any computer has a NIC card, and any NIC card has a MAC address which is unique. Then the network layer, which is layer 3, which is the IP address layer. And there is two types of IP address. And it is, for example, it is a logical, you can say a logical layer. It is the IP address is, for example, if let's say we have two computers, they wanna talk together. I mean, they wanna like move one file from from the application layer to the application layer. Like for example, one computer wanna connect to a server, email, website, and so it's the packet gonna start from the application layer, which is basically the browser, then the presentation layer. Also, it is in the I think the application layer and presentation layer kind of similar. They kind of almost done by like it's not in defined in it's not important in networking world, but it's like the session layer is like encrypting the data. The transport layer, there's two types of transport layer. There is TCP and UDP. TCP is a connection-oriented protocol. For example, like if a computer talk to a website, they're gonna send a request to the, for example, port number 80, which is www, which is the website port. So it's then the server gonna send an acknowledge through the TCP layer, an acknowledge. What they call it is ACK. Then the computer gonna send also an ACK also. It's like three-way handshake, they call it. They call it three-way handshake. Then as I said, it's like then the application going to choose the people who program, for example, the software going to choose for you which is TCP or UDP. They're gonna program it in the program itself. I mean, in the software that they are using. So the computer is gonna choose either TCP or UDP, and UDP is a connectionless. TCP is the connection oriented, and UDP is connectionless oriented. Like there is no acknowledgement. It's like delivering the package and hope it will get there. There is no guarantee. So, and why we need a UDP? We need the UDP because, for example, like real time, like for example, if we doing like voice over IP, like there is real time package. I mean, there is no need for if a package get dropped to resend it to ask the computer to resend it again. So that's why we need UDP. And sometimes and the other time we need TCP. Like if you're doing a transaction between your computer and the bank for your bank, for example, we need TCP. Then we come to the network. I mean, the file, as I said, is passed from the application layer to the presentation layer, through the session layer, through a transport layer, as I explained. Then the packet will get to the network layer. The network layer is the logical internet protocol, which is, there is two type of IP addresses. There is IP version 4 and IP version 6. First, I'm going to talk about IP version 4, which is there is also like two type of IP version 4, which is the public IP and the private IP. The private IP is like that you use it in your LAN, and it is start from there is class A and class B and class C private IP addresses. Class A start with like 10.0.0.0 /8, 10.0.0.0 /8, or 255.0.0.0. So it is this is the class A private IP address. Then class B is starting with 127.16 to 31.0.0. This is /16 or 255.255.0.0 255.255.0.0. Then class C private IP address, which is 192.168.0.0, which is 192.168, then dot anything after that. So it is also /16 or 255.255.0.0. This is the private IP address, and we're going to talk about how to the private IP address get connected to the public IP address through a NAT translation, which is a network address translation. That's called NAT. So now I'm going to talk about the public IP addresses. So the public IP addresses, also there is three classes, which is important. Class A, which start from 1 to 126. This is the first octet, or that what you call it, the first octet, which is from 1 to 126 of the IP address of class A. It started from 1 to 126, and it is /8. The subnet mask is 255.255.0.0.0. And what is the subnet mask by in any way? What is the subnet mask means, and what is the IP address? To understand that, we have to understand that this is like the decimal and the binary. So it's the IP address, for example, 10.10.0, for example, or .1. This is when I say 255 the IP address, I think, for example, as I said, 10.10.10.0 slash 24, that's 255.255.255.0, which is like the 10. 255 means we have to convert that to a binary, which is 255 means 8 ones. When it is a power of 2, it is like 1 and 2, 4, 8, 16, 32, 64, 128, and it's a power of 2, and it is like defining between the IB and the network. So it's basically like let me give a simple analogy. Like for example, if you're sending regular mail through post office, you're gonna need the address, the name of the person, the name of the city, the name of the zip code. The same thing. There is we need the IP address, like a public. It's like and it is like the zip code of the in the post office, and then we need the subnet mask, which is it's like a network. It's defining. I'm trying to. It's like as I said. The 0 is the host. When I say 10.10.10.0, 0 is the host and 1 is the network. So let's complete the we said there is class A, which is 1 to 126/8, class B, which is 128 to 192, slash 16, and again slash 16 means the subnet mask is 255.255.0.0. Then class C, it's like it is class C is 190. I think this to 192 to 191 or 192. I'm not. Don't quote me in that. This I think is 192. So it's from 192 to 224. This is class C, which is 24/24, and the subnet mask is 255. I mean, /24, that means it's 255.255.255.0. The subnet mask of the class C. This is, as I said, we're talking about the public IP address. So if we see here, the 127 is missing. So the 127 is a loopback testing IP address. So what else? There is also 224 to class D, which is for broadcasting, and it is 224, I believe, class D. It is 224 to 224 to 224 to, I can't remember, it's 224. Is that the broadcasting? It's reserved for broadcasting. Like for example, the when we talk about the OSPF, it uses this broadcasting to talk from, for example, the if a router wanna talk to the designated router, or it use the broadcasting, which is, I believe, 224.0.0.5 and dot 6. One of them is like a designated router to talk to. We're gonna talk about this in the OSPF. This is there is a class E, which is it is experimental class. Basically, class E, we're not gonna care much about it, but so this is the IP address. This is a network layer. So as I said, if a computer wanna talk, a computer, let's say this is let's say this is computer A. Wanna talk to computer B in here. B, which is it can be a server, or for example, like if it's like in a local area network. So the package from computer, how it get transferred. I mean, you send the packet from a computer, then it will get to the other computer, or to a server, and what the mechanism behind that. So as I said, the packet start from the application layer, then get encrypted in the session layer. Then the packet the software gonna choose, as I said, between the TCP or UDP. Then the network layer, the IP address of the computer B, and if it is in the same network, then it will pass to the computer will send an ARP packet to the computer, asking who is, for example, if this is the computer, had the computer A, for example, let's say has 10.10.10.2, and computer B has 10.10.10.3, for example. So it's a private, it's in the same network. You look as a subnet mask, which is 255.255.255.0. And you're gonna look at it and you're gonna say, this is we're talking about private IP addresses, and you look at it and you say this is 10, it should be class A. This is why we have to understand. We have to look at subnetting. We can subnet class A to make it class C. So this is another thing. Let's go back to the example we have here. So computer A send a packet. When it get to the IP address, it look at it and it find it. It's in the computer. For example, in my computer here, if I initiate command prompt, and I said I write ipconfig, which is a Windows command /all, and we'll look here. It's been, for example, it's been put or written in the, for example, for the Ethernet, the VMware. Let me talk about the wireless, for example. The wireless, it is 10.10.10.2.25, which is the LAN that I have in my home. I have 10.10.10.1 is a router, so it's a class C, and its default gateway also is assigned. It's 10.10.10.1, and this is the IP address, for example. So in any each computer, as I said, like computer A will have the same configuration, and computer B will have the same. But sometimes the IP address gonna be either in the same subnet or different than in a different subnet. So if it's like in a different network, either it's in the same network, the two computers either is in the same network or in a different network. If it's in the same network, then the computer A will send an ARP request, which stands for Address Resolution Protocol, and it is a protocol that basically will say who is 10.10.10. Computer A will say who is the 10.10.3, and the computer B, and it will get like broadcasted through the switch. The switch will do that. The switch will deliver either. We're gonna talk about the switch later, but it's like it is it's as simple as like the computer A, as I said, will say who is 10.10.3, and the computer B will reply with the MAC address. Then the bucket, it's like it is the bucket had the header, and this header has the portion for the physical layer, the data link layer, the network layer. So it's like filling this header with, for example, the network layer is 10.10.10.3. Then the data link layer, which is the MAC address of computer B. Then when it get, then it will get there. But if it is, if let's say this computer A is sending a packet to computer B or to a server, is not in the same network. Let's say it's in the public or in the internet, for example. So computer A will it's 10 that I'll keep it the same, but computer B, the IP address is, for example, let's say 8.8.4.6, for example, slash. So the computer gonna look at it and it's gonna say it's not in the same network. So it will, it is already, the computer A is already been programmed. I mean, not programmed, configured with the default gateway. So the packet will go from computer A to the default gateway of the router. Then the router will route it to another router, and from another router it will go to another router until it reaches its destination. So it's this is another thing. It's what is the router? A router is a device that route packet that, I mean, move the packet from one network to another network. And what is a switch? A switch is used for a local area network, which is like connecting device together in a LAN. Let's then this is the basic. Now I'm gonna talk to about what is routing. Let's as I said before, there is, if it's in a local area network, or if it's like an enterprise, not a local area network. It can be not a local area network. It can be like, if it's an enterprise, a big company has many branches, they can have one network. So it's and the routers and can has many routers, and as I said, the router route package between. So there is a static IP, there is static routing protocol, and there is a dynamic routing protocol. I mean, I'm moving now to the functionality of a router. Example of a static routing is like the administrator will put, for example, static routing, and as I said, there is a dynamic routing with routing protocol. For example, like RIP version 2, OSPF, EIGRP, ISIS, and so on. So now I'm going to create a topology in GNS3. So I have a virtual machine. It's Ubuntu. I have VMware player. I downloaded VMware player. Then I downloaded Ubuntu on it, and it's a virtual machine. And I downloaded DNS3. DNS3 is very nice. Like if you want to do like a virtual networking lab. So let's start the DNS3. It's already been started, but let's see if I want to start it. So I'm gonna close it. So from here, I'm gonna type sudo DNS3. I will enter the root password. Now the program start, the DNS3. Okay, and it's gonna ask me for a project name. I already have a project name. Automate. Okay, now let's bringing, for example, a router. This router, I'm gonna configure it as to be a host, like to be a regular PC, which is with a command called no IP routing. So to turn the functionality of the router to not to be a router. It's like if I want it like to be like just a PC with an IP address. So I'm gonna have two routers or two PCs, the router one, router two. Then, for example, I'll connect them with a switch. Let me connect them with the switch, layer 3 switch. There is layer 2 switch and layer 3 switch. Layer 2 switch is just a regular switch, like laying the MAC address. But layer 3 switch is like a router inside of a switch. Like if you wanna, if the switch, for example, had VLANs on it, you can have, like, for example, in a company, sales VLAN, engineering VLAN, IT VLAN. So if you want to do routing between them, you can do either a router on a stick, which is like having a router to route between the switches, or layer 3 router, which is basically like a router inside of a switch. It is an amazing device, layer 3 router. So let's bring in another router. Let's say this is like a public, and another router. Then another switch. And another router, and another router. Let's connect them together. Let's connect them together. Fast Ethernet 0/0 to the 1/0. Then 0/1 to 1/1. Then I want to do layer 3 routing, so I'm going to choose 0/0 to 0/0. I'm going to choose 0/1 to 0/1. Then I'm going to choose 10 to 10. Then 11 to 10. 12 to 10. Let's bring the name, I mean the interfaces of the router. So I'm gonna say show interfaces. So I'm gonna run this topology. It's like I'm trying to create, for example, like this is this here right here is for example an example for a local area network. This is right here is an example of a wide area network. It can be frame relay, as I said, or anything, or MPLS or anything. I know how to configure frame relay. It's easy. It's not difficult. There is basically dulces, and there's two type of frame relay: point to point and multi-point. This is another another knowledge. So let's now talk about this topology, and this is as I said, like another LAN. So, for example, this can be from the headquarter of an enterprise to a branch office. So, like a LAN from the headquarter or from a branch through a WAN to a LAN in other branch office. So let's run the topology. It's running. Okay, now let's bring the command prompt or the console. I hope the GNS3 doesn't crash because it's like a big topology. So let me see uh, what is going on. Okay, it's starting. Okay, I was just getting impatient, but it's now that the console is. So now I will start from router 1 and router 2 to turn them at the PCs. So where is router 1? This is switch. This is switch 2. This is router 1. Router 3. And router 4. Where is router 2? This is router 5. This is router 1. So I'm gonna press enter to get to the console. It is booting up. The router had this is a Cisco router, which is an emulator to a Cisco router. So it's like it has a Cisco image, and it is booting from the flash to the from the flash to the NVRAM. No, sorry, from the NVRAM to the RAM, or from flash to the RAM, which is the flash is non-volatile, and the RAM is volatile, but the RAM is much faster. So now I have the routers boot up. I mean booting up. So let's just wait. It's kind of slow, as I said. It needs this kind of topology. I mean, when you have like, for example, if you have a large virtual lab or large topology, you need to have like in your laptop has to be a lot of RAM. Like if it's like 16 or 32, it will be nice. I mean, it will be. But I have this laptop and I have only 8 giga. So now it's the router is starting. Still okay, still booting up. So now I have the console. So I will start first by show version to show the version of this router. Let me bring it like I said show version, which is give me this is the 2691 router, which is 2691. This is the 26 dash adventure. This you see this here, this 2691. That is the iOS image. So this is giving me the information about the router, and now I can initiate the command show interface show IB interface brief, which it will give me. I have fast internet 0/0, 0/1, and 1/0. So I'm gonna type config T or configure terminal to get from the user mode to the privilege to the global command mode. So I type configure terminal, then I got into the privilege. I mean the global command mode. So here I can say no IB routing. No IB routing. This is will turn if I try to let's negate that. Let's say no IB routing. And I mean, sorry, let's negate that. Not no, just IB routing. The command IB routing to make this device a router. You type the command IB routing. You want it to be a dumb device or like a computer, an end device. You can say no IB routing. I mean, write the command no IB routing. So if I initiate the command show IB route to look at the routing table, show IB route. This is a routing table and it's empty. So now I'm going to make it an end user device. So I'm going to say no IB routing. So now if I initiate the same command, do show IB route, you see it has no routing table. So now I will give the router an IP address. Then it is very easy. Like you go to the interface, like interface fast Ethernet 0/0, and you go inside the interface mode and you give it IP address. You type the command IP address. It's easy. For example, I'll give it there is 10.10.10.2, and the same that example in 24-bit subnet mask. So I'm gonna just increase the speed of this demonstration. So it's for example, let's get to the topology. Let's get to the topology. So it's router 1, okay. Now I can go to the topology to look which router. Okay. Okay, so like for example, router 3, this is the border router between the LAN. For example, as I said, this is a LAN and this is another LAN. This can be, as I said, like a branch LAN. So router 3 and router 4 are border routers. So the router 3 and router 4 can run a routing protocol, or it can we can use an static protocol, but it's just like it's easy to configure a static protocol. It's just IP route, then the other end, the next hub IP address with the subnet mask, then with the like to get to this router, you go to this router. This is the analogy behind static routing. But the dynamic routing is much easier, and it is the administrator doesn't have like to go to each router and initiate a routing. It will convert converge, that's the word I'm looking for, between the 2 or 3 or 4 or many routers, and as I said, this is like RIP version 2 and OSPF and EIGRP, and RIP version 2 is classless routing protocol, and RIP version 1 is class routing protocol. RIP version 1 was like in the 60s, 1960s, that was a long time, but RIP version 2 is like a little bit advanced, but it kind of has routing issues, which is like loop in the routing, and because it uses hub count to move a packet from a router to another router. But OSPF is more advanced, and it's easy to configure OSPF. For example, you say, let's say, let's go console. This is router 3. It's easy. You say config T router, for example, router OSPF, for example, 1. Then you press enter. Then let's see what the command we have. We have a lot of commands. We can create network. It's easy, but I will speed up. So as I said, the network routing protocols, it's like have many categories, like RIP version 2 and EIGRP. They call it they call it distance vector routing protocol, and the OSPF, it's more sophisticated, and it is they call it link state routing protocol. So it's it's easy, and it uses the DR and BDR, the OSPF, I mean, like the routing table, and it's easy. So I'm just gonna speed up, and I'm gonna stop the video right here. But as I said, I made this video because I I don't know how to do the talking, you know. It is like I mean, you guys tested me day before yesterday, I believe, like in my knowledge, and you wanna like say that I'm a liar, like I don't know networking. I'm not a liar. I don't lie, and I don't pretend. I will tell the truth, and I when I know some, I don't do plagiarism, and I don't do cheating. So that's it, and have a nice day. Bye. دقيقة بس يا موسى، قاعد أسجل بس دقيقة. لا لسه، ما الكمبيوتر علق لأنه